A plane is landing in Osaka Bay on an island that should not exist. There was no land here. Engineers made it out of 3 flattened mountains and dropped it into the sea. And from the moment they finished, the island began to sink. It is still sinking right now. Underneath the terminal building, in a space most passengers will never see, there are 900 columns holding the airport up. Every one of those columns sits on an adjustable jack. Everyone has a gauge on it, and every couple of years, engineers go down there, read the gauges, find the columns that have dropped too far, and physically lift the airport back up, one column at a time. This is Kansai International Airport. It cost around $20 billion. It handles tens of millions of passengers, and it only stays level because people keep making it level forever. To understand why anyone would accept a deal like that, you have to understand what Osaka was facing in the 1980s. Osaka is one of Japan's great cities, and it had an airport, Itami, sitting right in the middle of the urban area. That was fine when it was built. It was not fine by the 1970s. The city had grown up around the runways, and now hundreds of thousands of people lived directly under the flight paths. The noise was constant. Residents sued, courts ruled against the airport, and a night curfew was imposed, which meant Itami simply switched off in the evening. Meanwhile, air traffic was exploding, Japan's economy was booming, international travel was surging, and the entire Kansai region, Osaka, Kyoto, Kobe, 30 million people, was being served by an airport that couldn't grow and couldn't operate at night. So the obvious answer was to expand Itami or build a new airport nearby. Both were tried on paper. Both were impossible. Expanding Itami meant demolishing dense city neighborhoods and adding more noise where the courts had just ruled there was already too much. Building somewhere else in the region meant the same problem in a new location. Japan is mountainous, and its flat land is exactly where the people are. Every square kilometer of buildable ground already had a city on it. Every solution ran into the same wall. There was no land, not land that was cheap, not land that was empty, not land where a 24-hour airport could scream all night without a lawsuit arriving in the morning, which left one idea, and it was ridiculous. If there is no land, make some, not near the shore, where the noise would still reach people, far out, 5 kilometers into Osaka Bay, in 18 meters of open water, surrounded by nothing but sea. Out there, an airport could run all night and nobody would hear a thing. There was just one problem with Osaka Bay: the bottom of it. Beneath that water sat a layer of soft marine clay, in places 20 meters thick, and underneath that, hundreds of meters of older clay and sand. This is not rock. Think of it as a giant wet sponge. It is full of water, and if you press down on it hard enough, the water squeezes out and the whole thing compacts. An artificial island is exactly that, pressing down on it hard forever. Not the terminal, not the planes, the island itself. Millions of tons of rock and soil spread over hundreds of hectares, standing on a sponge. So the engineers knew, from the very beginning, that the island would sink. That was never in question. The question was how much, and whether they could get most of that sinking to happen before they built anything on top. Their answer was to drain the sponge on purpose. Before a single truckload of fill went into the water, they perforated the seabed. Over 1 million vertical sand drains were driven down into the clay, tightly spaced, each one a column of sand acting as an escape route. Squeeze the clay, and instead of water being trapped inside it, the water has somewhere to run. The clay settles faster, and crucially, it settles on a schedule engineers can predict. Then they built the island. Roughly 180 million cubic meters of rock and soil, quarried from mountains that were cut down for the purpose, poured into the sea and held in place by a seawall made of tens of thousands of concrete blocks. They deliberately built it too high, calculating how far it would settle over the coming decades and adding that height in advance. At several points, they simply stopped and waited, letting the new weight press down and the clay give way before adding more. On top of that, they designed a building that could survive the sinking. The terminal, designed by architect Renzo Piano, is a 1.7-kilometer sweep of steel and glass, and it does not rest on solid ground. It rests on 900 columns, and each column sits on a hydraulic jack with a gauge to measure how far it is dropped. If one corner of the airport goes down faster than another, thick iron plates can be slid in underneath and the columns lifted back into line. The runway surface was made deliberately flexible for the same reason. The airport was designed from day one to be repaired forever, and then it sank more than they predicted. By the early 1990s, before the airport had even opened, the first island had settled around 8 meters, roughly 3 meters more than the original forecast. That is not a rounding error. That is a very expensive surprise, discovered when it is far too late to start again. The clay was more compressible and more variable than the models had assumed. Engineers went underneath the terminal, inserted iron plates under the jacks, and raised the columns in stages, chasing the ground down as it fell away. The airport opened in September 1994. 4 months later, the Kobe earthquake struck, a magnitude 6.9 disaster that killed more than 6,000 people and wrecked buildings across the region. Kansai, sitting on a man-made island of loose fill in the middle of a bay, is exactly the kind of structure you would expect to fail catastrophically in that scenario. It survived with minor damage and kept operating, serving as a lifeline while the region recovered. Then, in 2018, Typhoon Jebi drove a storm surge over the seawall. The runway flooded, a drifting tanker slammed into the bridge connecting the island to the mainland, and thousands of passengers were stranded on an airport island they could not leave. In response, the seawall was raised and more money went into the jacking system underneath the terminal. Today, the sinking continues, but slowly. The dramatic early settlement is long finished. What remains is a creep of a few centimeters a year, monitored constantly at hundreds of points. Over its life, the first island has settled something on the order of 12 to 13 meters below where it started. Engineers still walk beneath the terminal, still read the gauges on those 900 columns, and still lift the ones that have fallen behind. There is no official retirement date for Kansai. Ask how long it will last, and the honest answer is, as long as people keep maintaining it. And that is what makes this airport different from almost everything else humans build. Most engineering aims for a finish line. You design it, you build it, you cut the ribbon, and the structure stands there doing its job while everyone goes home. Kansai has no finish line. The island was never going to stop moving, so instead of pretending otherwise, the engineers built the correction into the design. The jacks are not an emergency fix. They are the plan. There is something almost human about it. We usually want our monuments to be permanent, to outlast us, to need nothing from anybody. This one needs somebody. Every couple of years, somebody has to go down into the dark under the floor, look at a gauge, turn a jack, and hold an entire airport up against the weight of the sea. The most impressive thing about Kansai International Airport isn't that it was built on water, it's that it was never finished, and it never will be. If you enjoy seeing how the world was actually built, subscribe. New engineering stories every couple of weeks drawn simply.